Hello and welcome. This is Cambridge O-Level Computer Science paper number 1, Computer Systems. The subject code is 2210. This is variant 2 of the exam. It is October-November 2023 exam. Let's start. Question 1. It says, malware can be used to corrupt data stored on a computer. Tick one box to show which cybersecurity threat is not a type of malware. So remember, ransomware is a type of malware. Virus is a malware. Worm it sticks inside malware. Phishing is not a type of malware. It does not store specific sort of information or corrupt data onto your computer. It just leads you to reply to a certain email or certain or lack or leak of information or certain part uh, without storing anything on your system. So that is phishing. So part A would be the right answer. Then comes part B. It says identify one example of malware, then those given in part 1A. So other any Trojan horse, adware, keyloggers, spyware, these are all types of malware. So just write them all. You can use any one of them in your answer. So spyware is one, uh, keylogger is one, adware is another case, Trojan horse or Trojan virus. Not, you can not say horse, just Trojan can be. So then part C, identify the type of software that is used to find and remove malware from a computer. So software that can be used, anti-malware softwares are there. Anti-malware softwares are the ones that are used to remove malware from the computer. So moving ahead, it says part 2, a register a register stores a binary number. So this is now my binary number. Give the denary number for the binary number stored in the register. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8-bit number. So remember, if we are, so this is an 8-bit number. So we have to convert it into a binary number. So my first space, and it starts from, or you can say this is the least significant bit. This is my most significant bit. So remember, it goes this way. So this is my least significant. This is my most significant. So it's a binary number. So it means that this is 2 to power 0. This is 2 to power 1. This is 2 to power 2. This is 2 to power 3. This is 2 to power 4. This is 2 to power 5. This is 2 to power 6. And this is 2 to power 7. Now, just simply in our working, so 1 multiplied by 2 to power 0. This is my 2 to power 0 multiplied by 1. Then for second digit, again, I have a 1 and I multiply it by the base 2 power 1. Then I have a 0 and I have multiplied 0 by 2 to power 2. Then I have 0 again multiplied by 2 to power 3. Then I have another 0 multiplied by 2 to power 4. Then I have 1, I multiplied with 2 to power 5. Then I have again 1, 2 to power 6. And then I have another 1 multiplied by 2 to power 7. So so expanding them further. So first value 1 plus 2 plus 0 plus 0 plus 0. 2 to power 5 is 32. 32 plus 2 to power 6 is 64. And 2 to power 7 is 128. And so this comes out to be, if we add all these together, this comes out to be 227. And this for denary to the base 10. So the number in denary would be 227. Okay, but this will be your answer. Then it says, give the hexadecimal number for the binary number stored in the register. So what will be the hexadecimal numbers? For hexadecimal numbers, remember, we have 0, 1, 2, till we have 9. They remain as such. Then we have, then we have 10. So 10 in hexadecimal is A, 11, B, 12, 13, 14, 15. B, C, D, E, and F. So these are my 16 numbers, and that is why it is called hexadecimal. So after decimal, decimal system is 10. After decimal, 6. That means hex. So hexadecimal means 6 numbers, including 10. So 6 numbers. So this is my hexadecimal system. And remember, these are represented by 0, 1, 2, till 9. Now we have this. So on the working space, so hexadecimal, 16 numbers, 2 to power 4 is 16. So we make a set of 4 numbers for our. So in the working space, we have 1, 1, 1, 0, 0, 0, 1, 1. So these are my 8-bit number. So starting from the least significant bit, I make set of 4 because of this decimal. So we are from base 2, we are converting to base 16. So from decimal, so this and this. So just if we are going to find out what these numbers are. So this is one part, this is the second part. So for this part, we have again this number correspond to 2 to power 0. This corresponds to 2 to power 1. This corresponds to 2 to power 2. This corresponds to 2 to power 3. Similarly, 2 to power 0, 2 to power 1, 2 to power 2, and 2 to power 3. So let's try to add them. So 2 to power 1 multiplied by 2 to power 3 plus 1 multiplied by 2 to power 4 plus 1 multiplied by, 2 to power 2, 1 multiplied by 2 to power 1 plus 0 multiplied by 2 to power 0. This is one part. Then the other part, this 0 multiplied by 2 to power 3 plus 0 multiplied by 2 to power 2 plus 1 multiplied by 2 to power 1 plus 1 multiplied by 2 to power 1. So this comes out to be, this is 8 plus 4 plus 2 plus 0. This is one number, and the other number is 0 plus 0 plus 2 plus 1. Okay, so this is 12, 13, 14. So this number is 14 and this number is 3. So remember, 14 in hexadecimal is E, is represented by E. So we can represent this as 14 and this can be represented as 3. So this will be my hexadecimal number. So my answer, let me change back to red ink. So my answer hexadecimal would be E3. This will be my answer in the hexadecimal. Okay, so moving ahead, it says a logical left shift of 2 places is performed on the binary number stored in the register. Complete the binary register to show its content after the logical left shift. Say, for example, let me give you another example. So I have 1, 0, 0, 1. So this is my number. So this is my least significant bit. This is my most significant bit. Or you can say this is my rightmost bit. This is my leftmost bit. Okay. So if I'm going to left shift this, so left logical shift 1, if we are going to shift 1, so it means that this bit is moved one direction. So this whole number will move in this direction. It means that what happens, this 1 will come here, this 0 will move here, this 0 will move here. So 1 will come here, 0 moves ahead, and 0 moves ahead. So these are these 3 numbers. So what comes instead of 1? We replace it by 0. So this is how a left shift is done. So our number, remember, our number was 1 1 1 0 0 0 1 1 1 2 3 4 5 6 7. Yes. So 8. So this one was our number. So if I'm going to do one left shift, my first left shift will be 1 here, 1 here, 0 0 0 1 1. Okay, and then I will be having a 0 here. Then another left shift will become 0 here, 1 here, 1 here, 0 here, 0 here, 0 here, 1 here. and this vacancy will be replaced by 0. So my number will be something like this. So this is my binary number, that is twice logical shifted by 10. Then part D, it says negative binary number or 99 needs to be stored in a register. So we have to store a negative number. To remember the concepts of ones complement and two's complement. Generally, two's complement is used to store a negative number. So complete the register complete the register to show a binary number that would be stored using two's complement. Show all your working. So for two's complement, so question is how we are going to take a two's complement. Two's complement. Okay, so we need to have a binary number first. First of all, first step is we need to have a binary number. So binary number for 99. So we need to create a binary number for 99. Okay, and so for binary, so first of all, create a binary number for 99. So if we have to create it, remember our last examples. This is how we converted a number from binary to decimal. So the reverse way we have to go. So we have to, again, first of all, we have to see how many bits we have. We have 8 bits. So we have to convert a 8-bit binary number. Remember, we have 1, 2, 3, 4, 5, 6, 7, 8. So the final output should be of 8 bits. So we have to convert an 8-bit binary number first, and its value should be 99. Okay. So first of all, just simply create a working space. So 99 base 10, its binary equivalent base 2. Okay. This is what we have to do. So let's say we have first number 2 to power 0, 2 to power 1, then we have 2 to power 2, or there is an easy way of remembering it. So just simply write 1, 2, 4, 8, 16, 32, 64, 1 to 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So for 99, which of these numbers should add up to give you 9? 64, no, it's greater than 99. 64, 128, no. 64, yes. 32, yes. 16, no. 8, no. 4, no. 2, yes. 1, yes. So this, if I'm going to use this combination of zeros and 1, this will be my 2-bit, or this will be my binary combination of 99. So just simply write the binary combination. So this will be 99 base 10 will be equal to 0, 1, 1, 0, 0, 0, 1, 1. This is base 10 binary. Now, if I have to store a negative, so negative 99 base 10 is 2's complement of 0, 1, 1, 0, 0, 0, 1, 1. So we have to take a 2's complement. So remember, when we have to take a 2's complement, the first step is to take 1's complement. Okay, so first of all, we take 1's complement. So we have 0, 1, 1, 0, 0, 0, 1, 1. 1's complement, just invert all the bits. So 1 will become 0, 1 will become 0, 1, 1, 1, 1 again 0, 1 again 0, 0 will become 1. So this is my 1's complement. And in 1's complement, you have just simply add 1. So add 1, if I'm going to add 1 here, what will happen? Okay. So now I have to add 1, these two together. 1 plus 1, 1, 0. Then I have 1, then I have 1, then I have 1, then I have 0, 0, and I have 1. So this number is actually my 2's complement or this is a binary number, and this is my representation of minus 99. So the answer will be 1, 0, 0, 1, 1, 1, 0, 1. This will be the equivalent to minus 99 in base 10. So just simply put this value over in the blanks. It will be 1, 0, 0, 1, 1, 1, 0, 1. So this is how your number will be, or minus 99 will be written in the number. So moving ahead, part E, it says the number this and number this are added. Add two binary numbers together using binary addition, give your answer in binary, show your working. So first of all, let's add these nodes to 0, 1, 0, 0, 1, 1, 0, 0. The second number is 1, 1. Then we have three zeros. Then we have 1, 2, 3 ones. Okay. Just add them together. 1 plus 0, 1. 1 plus 0. Oh, sorry. 1. Then we have 1 plus 1. We have 1 here. Then we have a 0. Then we have 1 plus 0, 1. 1 plus 1. So now 1 plus 1, we don't have 2. So 2 in binary is 1 and 0. Remember, 2 to power 0, 2 to power 1. If we have 2 bits, so 0 will be here, 1 will be, so 2 in decimal is represented by this in binary. Okay, so we have 1 plus 1, 2. So 2 in binary is 0 and 1 is carry. This is carry here. So again, 1 plus 1, 2. 2 and 2 is written as 0, 1. So 0 is 1, 1 is carry, and this carry comes here. So if we have an 8-bit number, so this is our overflow. Overflow. Okay. So our answer will be, so the answer will be 1, 0, 0, 1, 0, 1, 1, 1, 1, with this as overflow. Okay. So just simply, if you're going to solve this, just write this, and your answer will be perfectly fine. Okay. So moving ahead, question number 3. It says a computer has a central processing unit that has a clock speed of 2 gigahertz. Then it says a user basically, or she wants to change the CPU that has a clock speed of 3 gigahertz. State what is meant by a clock speed. So clock speed is basically the maximum number of instructions that your CPU can perform, because CPU has an inside circuit that generates these ones and zeros, or basically a signal, something like this. Or if we are going to plot the waveform, it looks something like this. On, off, on, off. And this is a repetitive periodic waveform. So this is 1, this is 0, this is 1, 0, and this is one complete time period. So this, and it keeps on repeating itself. And this is actually a clock. And generally for a CPU, your one instruction takes 1 clock cycle, 2 clock cycle, 3 clock cycle. And that is how the instructions are mapped, and your instruction set defines it. So we can just simply say that maximum number of instructions a CPU can perform in 1 second is called the clock officer. Then it says, explain the effect of change of will have this change will have on the CPU. So basically, she's moving from 2 gigahertz to 3 gigahertz. Okay, so basically, performance will be increased because the more number of instruction the CPU will be able to perform with the increased gigahertz, and overall the system will become faster. So just simply write in words. So increase in CPU performance as more number of instructions slash tasks can be performed in same time. Or 1 second, you can also write the computer, or you can say CPU comes faster. Okay, this is a good answer for this. So again, remember, you have to mention, so it's a 2-point question. You have to mention two things. The important things are performance increase because the CPU speed is so increase in CPU performance as more number of instructions. So, increase in performance because of the more number of instructions that can be performed, and CPU is becoming faster. So moving ahead, I'm sorry. Moving ahead, it says the CPU contains a memory address register, or MAR. Describe the role of memory address register in fetch, decode, and execute cycle. So basically, how our CPU works is that we have once we give an instruction to the CPU, the instruction goes into first of all, it generates a code, and that code goes from the fetch mode. It fetches the information from a certain register, then decodes it, and then completely executes it and stores it in the memory or loads it in the memory, depending on the nature. So MAR register is the address is the register that basically stores the address from which they will be fetching that data, or the information from which we are going to start the execution of our instructions. So basically, MAR, memory address register, stores, or you can say contains, the address from which the data will be fetched for execution of CPU instructions. Okay. This is one case. The other can be MAR also stores the address at which the data will be stored or sent, as we have written earlier, via system bus. Okay, these are the two definitions which are, or two ways in which you can write this information. Both are fine. I generally prefer, my preference is this one, because it gives us give us information of both, that this register can be used to extract the stored information, or can be used to rewrite or you write, or you can say store the information that is received by after certain processing. So going ahead, part C, it says the CPU has a list of machine code in commands that it can process. State the name of the list of commands. This list of command is the instruction set. So remember, some of the CPUs which we're doing currently, we have RISC-V RISC-V instruction set. That is pretty common. It's an open source instruction set. Most of the CPU or processor companies are using this architecture. There are other architecture, computer architectures of the instruction commands such as MIPS that are available, or the CPUs in your, for example, cell phones, laptops, handheld devices, other components. They are basically using, or any device that is using a processor in it, that is either made or on certain made on certain type of instruction set, and it can be either RISC based instruction set or MIPS instruction set, things like this. So just another little side information for you guys who are listening. So moving ahead, it says question number 4. Question number 4 says, a washing machine is an example of an embedded system. Give two characteristics of an embedded system. So first of all, in an embedded system, it has a certain processor in it, and or it has a dedicated hardware. It is specifically programmed to execute certain functions. It's a real-time system. Generally, it's low powered, and it requires specific software or that is burned into it, or we can sort of call it as firmware. So all these properties are of an embedded system. So I'm writing all of them. You can use any of the two of these properties. So you can say it has a processor. It has a processor, microprocessor. Now we have interestingly nano processors coming. Microprocessors in it. It has a microprocessor in it. It has dedicated hardware. Okay. It is a real-time low power system. It is a real-time low power system. It has it requires specific firmware, which is written inside the memory of this device. It is specifically programmed to execute or to execute specific functionalities. Okay, so any of these two would be good enough for you to answer this. Then part B says circle 3 other examples of embedded systems. So with other examples, so remember, embedded systems, these are specific systems or devices that are developed to execute certain functionalities which are not computers. So remember, do not circle laptop, personal computer, uh, web server, so smartphone. So these are actually not your embedded systems. So any three of them, so the remaining, the freezer, light security light system, vending machine, these are all your embedded systems we have. So moving ahead, question number 5, it says a band is recording a new song. They need to consider the sampling rate and sample resolution of their recording. Okay. So give one benefit of using high sample rate to record the song. So remember, for example, if I'm going to show you with the help of a waveform, it would give you a better idea. So this is, for example, with time, and if you are speaking in a mic, your voice signal would be something like this. Okay. So, and you call it as amplitude. Amplitude of your voice is something like this. Oh, okay, let me a little bit. Okay, something like this is your voice signal. So what you are doing is when you are sampling it, you are basically making it discrete. So at certain instances of time, you are taking the value of these samples and storing it somewhere. Okay, something like this. You are taking up these values and storing. So these blue lines are the points in time where you have the samples. or you have taken these discrete values and stored into a RAM. So this is one. So what if I have less sampling rate? It means that some of these values are missing. Say, for example, these values are missing from your information because my. So what will happen? So if you're going to recreate this signal or recreate your voice, this recreation won't be like what you have spoken. So there will be some information that is not present or that is lost when you are going to recreate this voice. So one of the benefits of higher sampling rate, it is that more accurate reading of song, less loss of information, uh, provides more accurate recording of the song and much less information loss. Okay. One drawback of using higher sample rate to record a song. So if you have more number of samples, you need a large storage space and the file size will increase. So one drawback, uh, storage size will increase, or the file size will increase. So the actual file where you have stored this information will increase, and to store that larger file, you need more space basically to store this. So moving ahead, it says describe what is meant by sample resolution. Okay, sample resolution. Okay, so that is an interesting case. So on the sample resolution, if I'm going to use this graph, is something like this, that over here, if you are sampling it, you're sampling on the x-axis. For the sample resolution, you need to information about this amplitude. And for sample resolution, again, you need to sample the y-axis as well. So the better the sample resolution, more will be the information you have on the amplitude of your sampled variation. So the better resolution on the y-axis, so on the resolution or is actually the y-axis. The more number of bits you have, more number of information or for a certain sample you can store, and that will give you a much better recreation of the signal. So what is meant by a sample resolution? So you can simply say that it is the number of bits that are used to per sample to store information. It is the number of bits used to store a sample. Number of bits used to store a sample of information. Okay. And for example, 8-bit, 16-bit, etc. Okay. For when we are talking about sound recording, so we are basically talking about the amplitude, variation in amplitude. So the resolution, or on the y-axis, we can say that for sound recording, it is the variation of amplitude that can be stored for each sample. Okay. Then part D, it says a band want to compress a sound file, but they don't want any data to be permanently removed. Identify the compression method that could be used, that should be used. Basically, they are talking about lossless compression. Lossless compression methods should be used. Okay. Then question number 6, it says the table contains description about data transmission methods. So data transmission methods part A, it says complete the table identifying data transmission methods are described. So first method is data is transmitted down a single wire one bit at a time in one direction. So remember, data is transmitted between two entities, A and B. Okay. From A to B only, and one bit of information at the same time. So it is a serial link, one directional. It means that is a simplex method. So it is a serial simplex method. Then data transmitted multiple wires. So you have multiple wires, multiple bits. So each wire will have multiple bits at the same time, both directions. So it means that the directions will be both, but only one in both directions, but one direction at a time. So you have a capability of information sending on both directions, but one direction at the same time. And you are also sending multiple bits. So multiple bits mean parallel communication, and one communication at a time, it means that half duplex. Then it says data transmitted down a single wire, one bit at a time in both directions at the same time. So it is a serial communication. You have only one wire, but it is allowing at the same time both connected with each other. It means that full duplex. Both users, if you're using a telephone, both users can speak at the same time. Then it says data is transmitted down multiple wires, multiple bits at a time, and only one direction, in one direction only. So it is again multiple wires, one single direction. So it is parallel because we have more multiple bits and multiple wires, but one direction only. It is simplex. Okay. So moving ahead, part 7. It says a train has a ticket inspector who checks each customer ticket before they are allowed to get on the train. The train station wants a system that allows the ticket to be automatically checked. Identify two sort of suitable input devices that can be used to automatically read the ticket. So you are basically, you intend to read. So reading a ticket, QR scanner can be an option. Okay. Then you have a barcode scanner. Scanner can be an option. Then you can also have a camera reader. You can also have an RFID tag based scanner. So any 3, 4, I suppose would be good. Choice can make it as camera reader. So any of these is a good choice. Then part say it says the train driver pushes a button to close the train door when all passengers have boarded the train. The train door will only close when there are no passengers in the doorway. The system to check there are no passengers in the doorway uses a sensor and a microprocessor. Explain how a sensor and microprocessor are used to check whether train door can be closed. So uh, here, what we have to basically consider is that, for example, this is a door of a train. This is my base, and there is a sensor and something like this, and there is a person that is standing. What is that sensor doing? Sensor is connected to a microprocessor. I call it as MP, and that microprocessor is then connected to controller that controls the door, controller door, and that basically sends a signal to a motor, and that motor is actually moving the doors and also sending a signal to the train driver, sending a signal to the train driver as well. So this is a complete architecture would look something like this, and this will work in a way that that once if somebody is standing in the door, the sensor will sense the person, sends an information to the microcontroller, and that microcontroller will generate a signal that goes to the train uh, driver that is or who is controlling the motor and the driver source, so that there is a person. Do not switch on the door. And once and what on how this will be happening is that the sensor will be continuously checking that area, and as soon as the sensor reading or sensor information gets enough range information that yes, there is no person standing in between, the door will generate a signal or the microcontroller will generate a signal to inform the train driver that yes, although there's nobody in the board, that you can close the door, and then the closed door can be closed. Okay, so let's try to write it. A sensor can be a sensor which can be IR, proximity sensor, IR sensor, placed in the door or in the doorway, sends digital information to the microprocessor. Okay, microprocessor. The processor compares the information with the stored information. With that, this information is basically about the range sensor digital information. We can call it about range. Store information to make a decision of closing the door via actuator. Actuator is actually a controller plus motor, we call it as. So what happens? So for example, if a sensor detects a person in the door, you can say if sensor detects a person in the door, the signal generated is out of range for the microprocessor. So if a sensor detects a person in the door, the signal generated is out of range for the microprocessor to activate the actuator to activated the actuator. Remember, our timer is also activated, which periodically checks uh, the which periodically check with the sensor, the sensor to share its data with the microprocessor. Okay. Once the data is in the range, the microprocessor sends signal to the uh, driver to activate the motor to close the door. Once closed, the sensor can again recheck and confirm. Okay, so this is how you can uh, write in your own words about this microprocessor based system that is working to close your door on the train. So moving ahead, question number 8, it says draw and annotate a diagram that demonstrates the cyber security threat of data interception. Okay, so cyber security threat. So data interpretation. So for example, you have user A and you have a user B who are communicating between each other. So say this is sending information here and this. So this is these are your communication links. These are your communication links. Then what we have, so if a cyber security threat is there, so some person will be hacking over here. It is so a third party spoofer, you can say, will come. Third party hacker. The third party hacker will basically comes and starts collecting the packet. So third party hacker, and it basically does what? Collects the packets, the data packets, and analyzes them for useful information. Okay. So this can be done by data packet sniffers. So data packet sniffer. Uh, uh, what does is it? The role of this is it examines the data and shares it with a database or share it with the third party. Okay, so this is how you can draw a diagram that is demonstrating a cyber security threat of data interception. Okay, So moving ahead, part B, it says identify one security solution that will help keep data safe from data encryption and state why it will help keep the data safe. So one technique is encryption technique. So you send encrypted data. Encryption technique is encryption. What the encrypted data is meaningless for the hacker slash third party without the decryption or the decryption key. Okay, so without the decryption key, that data is useless for the third party. So next, question number 9. So it says complete the table with the missing terms and item. So description is a collective name for web pages available. It's World Wide Web. So www or World Wide Web. So remember, do not write www over here. This will not give you good complete credit. Then it says a small file stored by a web browser that can store a user's personal data. This is called cookie. So, okay. Then it says uniform resource locator. So URL is a text-based address for a website. Again, it's also a protocol, and it is made up of there is a protocol. There's a information about domain name, file name. Yeah. So URL, it is a text-based address for a website. It is made up of protocol, domain name, and file name. Okay. Then we have a web server. So web server is a computer or a location that hosts or stores certain web pages. It receives requests from different clients and returns the requested web pages or information associated with them. So again, it is a computer or a host server, host or location as well as hosts, or you can say stores web pages. It receives requests from clients and returns requested information. Okay, this is how. Then it says describe the language used to create a website, HTTP. Remember HTTP and times are head copy. So oh sorry, not H. My bad. It's not HTTP. It is HTML. So it is HTML language. You have to write the complete name. It is hyper text markup language, or HTTP. Okay. Then it says a protocol that is used to request and send web. This is HTTP. This is HTTP, hypertext transfer protocol, HTTP. This is hypertext transfer protocol. Okay. So moving ahead, question number 10, it says a business has a system that is described that is described as having an AI intelligence outside having sorry, a business has a system that is described as having an artificial intelligence. State one of the main characteristics of an AI system. Um, so AI system has an ability to collect and learn from the data. It can also analyze and adapt to the data. Okay, so this is what an AI system can do. Then it says, excuse me, an AI system is an expert system. Explain how an expert system operates. So again, it's an AI expert system. So an expert system operates through a user interface, facilitating data input and output interactions. The core of the system includes a knowledge base storing domain specific information. It also have a rule base containing logical statements and an inference engine. Applying knowledge and rules to generate outputs and results. Okay. So then it also has a decision making. So the decision making process involves systematically applying results to the knowledge base, ensuring Sorry, accuracy in recommendations. Uh, System, okay, the system can dynamically decide to be next inquiry based on the user inputted data, adapting itself to the specific problem. So overall, you can say that the cohesive integration of uh, user interface, knowledge base, rule base, and inference engine enables an expert AI system. Okay, so this is how you can write, or you can show detail about this. Moving ahead, 11, question number 11, it says a manufacturing company uses an automated system in its manufacturing process. The automated system uses a flow sensor. Identify what a flow sensor measures. So flow sensor measures basically the amount of a fluid, usually liquid, gas, flowing, moving, or passing through a system. Okay. Then it says explain one advantage or one advantage to the employees of using an automated system in manufacturing. Um, uh, Increases productivity. It improves, you can say, safety, saves uh, precious working hours, which can be utilized on other tasks, which can be utilized on other tasks. Moving ahead, it says part C. It says explain one disadvantage of the company owner of using an automated system in the manufacturing. It increases cost of maintenance, uh, you can say manufacturing, and requires expensive, skilled labor. Other costs, other disadvantages, reduced number of jobs. So, but this is generally not a domain of the factory owner or a company owner. It's not much concerned. The governments are most generally concerned about that. So, anyways, moving ahead, question number 12, it says digital currency can be used to pay for products and services. Digital currencies are often tracked using digital ledgers. Give two other features of digital currency. So actually they are electronic or paperless. Paperless. Uh, they are decentralized, or in some cases, or can be um, centralized. They are encrypted. Or they can be encrypted, or it will be untraceable. Okay. Then it says part B, identify the process that uses digital ledger to track the use of digital currency. This is the blockchain process. Blockchain process, this is the process that is used. So moving ahead, last question, question number 13 of this exam says storage and memory are important components of a computer system. Primary storage is one type of storage in a computer system. Take one box to show which is an example of primary storage. So compact disk, no. Secondary hard disk, no. Secondary random access, yes. Solid state drive, no. So the answer is this C. Random access memory is the memory that is the primary access memory. Then it part 2, it says give one characteristics of primary storage. It is volatile and can be volatile and can be not. So it is then directly associated with the directly accessed from the CPU. Directly accessed via CPU and the oh, can be volatile and also non-volatile as well. Okay. So going ahead, it says part B, a virtual memory can be created in a computer system. Complete the description of about the virtual memory. Use the terms from the list. Some of the terms in the list will not be used. Some of them may be used more than once. Okay. So virtual memory is used when the RAM or the is full. So you can use this when the random access memory RAM is full. It is created by partitioning the hard drive or hard disk drive. Yes, hard disk drive, HDD. Data is divided into pages that can be sent from the RAM dash to dash, from the RAM to the HDD, or from RAM to the hard disk drive to be temporarily stored. Okay, until they are required. So temporarily stored can also be in the virtual memory. Yes, address you can also write virtual memory as here. Okay, so this is how you solve this question or write answers to them. So this is the end of it. I wish you have understood and learned from this video. And if you need something else or more information about papers, please do message me. And in the end, I'd like to wish you best of luck for your exams and happy learning. Take care.